programming workshop. I'm Ayush and that's Vinay. So we're going to start by just setting up VS Code and get you all, you should be able to deploy to the robot at the end of this. So how many of you have created a GitHub account? Everyone except you. And you're working on that, right? You're working on that?
Yeah.
Okay. So, and how many of you have been added to RoboLoco GitHub? Okay, and if you haven't, check your email, because they probably sent you an invitation that you haven't accepted yet. So that's most people, I think you can go. How many of you have downloaded VS Code? Okay, that's good. Have you guys downloaded VS Code? Okay, good. So I guess we can move on to setting up accounts. So how many of you, so everyone who has VS Code already installed and downloaded, open it up. Okay, so once it's opened up, go to the very bottom. It should be something called Marketplace or Extensions. And search up the Java extension pack by Microsoft. So that's useful because it has neat autocomplete features, especially if you're not too familiar with Java. It'll help you get the basics settled down. So you should just be able to click install and you'll have to restart your VS Code and you should have that all installed. So let me know once everyone's got that updated.
If we did those 5 extensions that you put into the video, is that
Oh no, that does not include the Java extension.
Yeah.
So now, everyone should have been added to GitHub, so go to GitHub and navigate to the RoboLoco repository. It'll look kind of like this when it shows up. So once everyone's at this repository, you should have been added to the 2019 off-season training, so click on that. You should click on over here, clone or download, and you should just be able to download the zip file, or if you're on Mac, you can copy that, and you can go to terminal and type git clone and paste that URL. I recommend just download the zip file and unzip it. Okay, so once you have the folder downloaded, open it up in VS Code. Okay, so although we don't have the robot up and running now, you guys should be good to go. And what you guys just downloaded was kind of a shell repository. And what that means is as we teach you stuff, this is just a place for you to play around, write some code. And probably every other meeting we'll have the robot out and you can test can I get input? Or can I make the robot drive a certain distance? So this is just something for you guys to play around in, just get you a framework to set up. And in the future, we're going to talk about this a little more, but one thing that's super important is something called the command palette. So if you download VS Code on the top right, you can see this little WPI logo. If y'all can click that for me, that'd be nice. Get the WPI. Okay, so for those who have the WPI command palette open, this is just everything F4C related. If you're going to create new files, this is where you're going to do it. So as we talk about later, we're going to talk about command subsystems. That's where you're going to create your commands in your subsystems. Tonight, most people have WPI set up. We're just going to actually talk about the code and get you started. And we're probably not going to get to this today, but in the future, we're going to split you up into groups, because one thing we like to do during the season is we can't have everybody working in one file, because the way GitHub works is you can override code. So what we like to do is we like to create branches, which we'll probably talk a little bit more about towards the end. And different components, we use different branches for different aspects of our robot. So for example, there'll be one for driving, getting the driving smooth, getting that working. There'll be one for our elevator, getting the robot lifting onto a platform or climbing. So we're going to do this later, but we're going to teach you guys branching using different groups. So now we're going to actually get started on the code structure. So FRC programming is extremely object-oriented, which means that every real-life thing has something associated with it in code. So we have a Talon, which is an electrical motor controller that has an object associated with it in code. So is everyone here somewhat familiar with object-oriented programming? Raise your hand if you have no idea what I'm talking about.
Yeah, I have the
1, 2, 3. Okay, so just to clarify an object, so let's say I have a bunch of data, right? I have numbers. An object just compiles methods and data into a single object. For example, let's say I have a computer. What can a computer do?
Oh wait, so you're good then. Alright.
Access the internet. What else? Sure. What else?
Watch the NBA draft.
Watch the NBA draft. So a computer is an object that can do multiple things. So that's essentially what an object in code is. It's just a variable like an integer or a boolean, which is just boolean is true or false. Integer is any non-decimal number, which has many methods associated with it. So for example, we have our talent object, right? Can anyone guess what that's going to do? So if I tell you a talent is a motor controller, meaning it controls motors, can anyone guess what a talent object is going to do?
It's going to control the robot's movement.
Perfect. So a talent object, it's an easy way. It'll have methods associated with it, which controls the robot's movement. So for example, another good example of an object is, let's say I have a class called a car, right? There are many different types of cars, which each have their different features. For example, I drive an old Acura, which doesn't have the updated features. But someone who drives a Tesla has a self-driving car. So there are different objects can be associated with classes, and they'll have different features associated with them. So if that just flew right over your head, in the email that I sent out a bunch of basic object-oriented Java stuff. So watch those videos. It'll be helpful in the future. So the main thing, the biggest thing is our robot. And since FRC programming is object-oriented, our robot is an object. So there are different types of robots that have different commands associated with them. The two most common ones are iterative robot and timed robot. What an iterative robot is you take one command and you're running it every 20 milliseconds. And an iterative robot accesses those commands every 20 milliseconds. However, a timed robot is basically an iterative robot that's more consistent. So what that means is a robot, depending on how you design your robot, you have to have different objects in code that can do different things. For example, I talked about earlier how different cars have different features. Depending on the features on your robot, you can create different robot objects that'll have different methods associated with them. So we use the time robot because it's more consistent and allows us to do multiple things. So all of FRC programming, if you take nothing away from this workshop, all of FRC programming is centered around the idea of subsystems and commands. What a subsystem is it's associated with mechanical components on the robot. For example, a great example of a subsystem is our drivetrain. The drivetrain are the four wheels and the motors that are associated with the wheels. Can anyone guess? Can anyone give me another example of a subsystem? Like anything mechanically associated with the robot. So an elevator would be a subsystem because those have motors and different moving parts associated with it. So a subsystem is essentially anything that's on the robot. A vision system, it's on the robot. There's cameras and sensors that's on the robot. What a command is things that you can do with the subsystem. Can anyone give me an example of what can I do with a drivetrain?
Drive.
Exactly. So a simple command for that subsystem will be drive forward. That's a command associated with the subsystem. So now, what's an example of a command that's associated with an elevator? Go up, go down, climb. So this basically the structure. This is what FRC programming is. It's just split up into subsystems and commands, or at least that's what we're using. So you take nothing away. Remember, subsystems are stuff that's on the robot. Commands are stuff that you can do with the subsystem. So now a little bit deeper into what a subsystem is. It's basically a mechanical component that the robot can move, or that is something that if you go look at a robot, you can point out, there's the subsystem. So common examples are wrist, claws, drivetrain, arm, climber. And subsystems essentially take abstract concepts. Like often in code, you have to figure out a way to take these like abstract concepts and turn them into something that's like concrete. And that's where this object-oriented programming and nature comes in. And what a subsystem is it takes your code and it makes sure it's linked to something on your robot. Because if you write code for something that's not on your robot, it's pointless. So a subsystem essentially links what you're writing in code to what's on your robot. So a command, like I said before, is an action done by the robot. So commands are actions, subsystems are actual things on the robot. So for example, some examples of commands are move a certain distance, rotate by certain angles. And by splitting actions into commands, we can reuse them in different subsystems. So if I have something that says move a certain distance, give me 2 subsystems that I can use for that. Wheels and
Elevator.
elevator. So I can move the elevator a certain distance, or I can move forward a certain distance.
Are you good?
And that allows us to reuse certain commands and makes it a lot more efficient when you're running code. And that's the big thing about programming, is you're trying to make things as efficient as possible. And this command-based system allows us to do that. So apart from subsystems and commands, we also have certain electrical objects that are associated with code. So one of the common things are motors. Motors are used to move certain mechanical components, and motors are controlled by these things I said earlier called talons. Talons are essentially motor controllers, meaning they control how fast and different attributes about how a motor moves. We also have things called solenoids. So very soon you're gonna learn about these things called pneumatics. What pneumatics are they use air pressure to move certain pistons. And solenoids, they essentially control when the pistons move. And we also have sensors and various other electrical components. So each of those have an object in code. So essentially you have your object in code and you have your object in real life. So FRC code is structured very similar to how a real game works. For those who don't know, an FRC works, there's a 15-second autonomous period. This year we have a sandstorm period where we just couldn't see. And then we have a 2-minute and 15-second gyro control period where you have driver input and you have driver output. So the scheduler, you don't need to know too much about that, but just know that it allows us to determine when the robot is in autonomous mode and when it's in teleop mode. Because when it's in autonomous mode, we can't get driver input. It has to be all autonomous. But when it's in teleop mode, we can get input.
So what would you use to program autonomous, right? So obviously this year was a bit different. We had the sandstorm period, which many of you, like this members were here last year, know that we basically had like a black cover over us, right? And we couldn't see when we were driving. And so a lot of that used the vision system, right? So what we can do is we can use vision tracking on like basically objects, right? And so if it has like a very distinct color, or in last year's case, we had the retroflective tape, right? So what the limelight does is that it reflects a green light, and basically if it's very reflective, if you turn down the exposure, that's basically all you will see. So you can put a bounding box around that and you can go and track that. Another thing is robot control algorithms, and so we use a library called Jackie Pathfinder, which it's basically black magic, in my opinion, because it just lets you like move around where you want to go.
So in the robot that we're using, Time Robot, there are multiple methods that can be used for autonomous, and all you need to know is this is going back to the scheduler thing I talked about earlier, because these methods signify that we're in autonomous mode. We can't get driver input, so we have to control the robot in different ways than if we were in teleoperate.
So with this year, since we basically used teleop in the sandstorm or autonomous period, all we did was in autonomous and autonomous periodic, we called the same methods we do in teleop and teleop periodic.
So in teleop, we control the robot using driver input, which means we get it from joysticks and controllers, and we can use buttons for certain functions.
So for Time Robot, I like it autonomous. We had autonomous in it and autonomous periodic. We have teleop in it and teleop periodic. These basically do the same thing as autonomous in it, or in periodic. And so what a teleop in it does, it allows you to initialize subsystems or commands, and periodic just keeps it running in a giant loop. And so the difference between autonomous and periodic and this one is that you are allowed to use driver input from here.
So before we move on to actually like talking about how we can get some driver input, I want someone who hasn't talked before to tell me what is the most important thing about the way that we structure our code.
What?
The two big words I said, if you know nothing else from this workshop, what are the 2 words you should remember?
If you need to.
Subsystems and command.
Okay.
Hey.
So someone else, tell me what a subsystem is.
It's the like parts on the robot.
Yeah, it's associated with mechanical concept. And someone else tell me what a command is.
It's like I take the subsystem and do stuff.
It's a command.
Yeah.
Okay, so now we're gonna talk about how to actually like code stuff. Okay, so we had you download that repository earlier. Can everyone open that back up?
I don't like
So
the last
essentially
thing
what
you
OI
did.
is,
So I
it's
went
our
all
way
back to
of
the
controlling input and output. So OI is just a file that if you're going to do any driver input, put it in this class. That way when someone else is looking at your code, anyone else on this team, they know that if I'm doing driver input, this is where I go.
So, axes, basically, an axis is basically kind of like, or is basically like basically a double value usually between -1 and 1. And so examples of these would be a stick or a trigger. Trigger's a bit different because it goes from 0 to 1 because you can't have the trigger, right? So each axis are basically with an ID. So the way you find this ID is when you plug in your controller to the driver station and you just like fiddle around with it and see which stick or which trigger like corresponds to which specific ID on the map.
So now if we go to OI,
Just open these.
you have it open. Okay. So if you have OI right here, and you go down to this function right here, get left joystick. You see here we have 3 different cases, X, Y, and Z. Since the controller can't move in the Z direction, we only have code under X and Y. And what that is you have your I'm assuming everyone here's seen an Xbox controller before? So you have your 2 joysticks on your Xbox controller, and each one of those returns an X, which is side to side, and a Y, which is up and down. And what we're doing here is raw axis 0 is side to side, so we get that as our X value, and then raw axis 1 is up and down, so we get that as our Y value. And essentially, anytime you have a joystick instead of a button, it's not a simple on or off. There's a range of values that you can get. So that's where raw axis comes in, when there's a range of values.
And not just that too. We can actually get to Z1. So the controllers we're using now is like those like Logitech controllers, right? So they're kind of like Xbox sticks. You can only move it up and down. It's up side to side. The other one we had, which is the one Andrew was using for driving, it's literally like a giant like big.
So there are
joystick.
multiple
It has a
controllers
Z on
that-
it as well, so where you rotate it. So
So
that's
there
where
are
you get the Z value.
Yeah, there are multiple controllers available for FRC. Up until last year, we used I don't know how to put it. It's like
Joysticks.
arcade controllers,
Yeah, arcade joysticks.
where you have 2 controllers and you drive that way, and that you were able to twist that, which is where the Z comes in. Now we're using an Xbox controller. You can't twist the little joysticks on an Xbox controller, so that's where that comes in. So if you guys want to play around with axis, and another thing we mentioned for axis is you can actually get your left and right trigger. So if you want to go up into this get function right here and press enter, you type in case left trigger : So let me know when everyone's done that.
We talk about buttons first, then go over that.
When we were started, so.
Yeah.
Is left trigger, is that a specific, did you define that, or is that?
Yeah.
yeah.
So you have to define that up here. I was gonna do that at the end, but since I was brought it up. Once you have the case down here, we have to define left trigger. So up here in this enum, type in L trigger. So essentially, anytime you're defining an axis, You're gonna start by putting the name of that axis in this enum up here.
Alright, this is gonna ask means button. Axis,
Button or-
you get, you
or
use
a
one of these
trigger.
like cases, character cases.
And then you add that to the get function. And once you have that case L trigger and you have your colon, you just tab and you can return your axis.
Now, obviously, what he's doing is returning a boolean, right? So if you have this double value, what's like kind of a simple way to convert it to a boolean in a way that if I'm holding the trigger down, it's on.
Make,
So if I'm not holding the trigger at 0, right, it's only the trigger and it's 1, right? So how do I convert that to a boolean in this case?
if it's between like 0.5 and 1, make it true, and then
Okay, why the 0.5 though?
because then it like rounds up to 1, so then it's like closer to 1. And then if it's like between 0 and like 0.499 whatever, then like just round it to false.
Well, I mean, rounding does not have much to do with it.
That's
It's more
great.
like a threshold value, right? You don't want to like touch it partially and it starts activating. You want it to go a bit more further.
So the easy way to do that is if you type your get axis is greater than, you said 0.5, and then you can type in your question mark, which is it greater than 0.5? And it returns true or false.
Yeah.
So what is that line telling us? What does that do? Is taking an input from
So
the
essentially, when you're connected, you have your two controllers, right? Which are the two controllers that we run, two controllers plugged into the computer. And this is the right one. And the trigger is your axis. And if the trigger is pressed more than halfway, then it returns a true value. If the trigger is pressed less than halfway, then it returns a false value. That's basically checking, am I pressing the trigger or not? So that way, let's say we want to map the trigger to move arm up. If the trigger is pressed, that returns the true value. So if that's true, then you move the arm. If not, then the arm stays where it is. So
So-
that's
is that line setting the threshold?
how you're getting the input. That's saying, am I pressing it or not?
So yeah, it is. Yeah, this specific number
And the
is
0.5
threshold.
is the
Yeah.
So it's
Wait.
setting the threshold so that you know that above 0.5 is
Yeah.
on and
Yep.
less is off.
Wait, so
Okay.
is that for like a for a joystick or for like a button?
You can do for both. We generally, when you're doing true or false, it's for a trigger, or because you can only have a threshold for an axis. Because for a button, it's either on or off. You've either pressed it or you haven't.
But the triggers you're
But
saying are
Triggers
analog.
are axis, or an analog input. From
Analog.
it can give you any
Okay.
value from 0 to 1.
Okay.
0 means it's not pressed at all.
Yeah.
0.5 means pressed halfway, etc.
So what you're saying is like the triggers, they return a value of how much is being pressed.
So if it's pressed more than half, then we're assuming
Okay. Yeah, I think that's what you need to clarify. So it's an analog trigger.
Yeah.
So you're converting an analog trigger to a
because a trigger
To
is an
a-
axis. Yeah.
true false input.
Yeah.
Now, obviously, it's more preferred to use a button, but there are cases where you might want to use a trigger instead of just a button. And the reason for that is that you'll often run out of space of buttons on the controller. So using a trigger is kind of a jank way of like just making your own button, I guess.
Vinay, so what you were saying before was that everything after the number 0.5 is redundant.
So no, like
Before
let's
it's
say
done.
you're driving, right, and you press the button a little bit, like accidentally.
I think he
No,
means
no,
like
no.
on the
He's saying
code.
why is it the statement?
Okay, so
He was talking about like
you have two. This is double var. This is a double value, right?
Mhm.
This is also a double value. You're comparing these two double values. So what are you returning here?
if it's greater, then it's gonna be true.
So what is that value? A true or false value? What is it called? What is it called? A
Boolean.
boolean, right? So what this is called basically a ternary operator. So it's basically just another way of writing an if statement. So if this like boolean statement is true, it's saying return this. If it's false, do what's after the colon. So that's false. So if it's already returning true, what he's saying is to return true again. Isn't that a bit redundant? Right? So what I'm saying is like write clean code. Don't waste these couple of bytes. It's not that big of a deal, but like this is bad, okay?
So like
Don't do that.
everything like the question mark and after that section is the redundant part.
No. Like in some cases, this is actually quite nice. Like there are some cases that will be quite useful. For example, when did you use turner operator?
When you're trying to like, let's say it's basically
Oh, when you're setting, like sometimes when setting variables or doing multi-line stuff, you can use in that case.
like ternary operators. What simplified is, does everyone know what an if statement is? Pretty much everyone, right? So ternary operators, let's say it's a very simple if statement. If this condition is true, then return a true. If it's false, then return a false.
It doesn't have to return a true or false. It can return another value.
Yeah.
Like,
But like,
Like, if you
if
wanted-
it's true,
yeah.
return before the colon. If it's
Yeah.
false, return after.
So,
like if you wanted to return a 0
Or
or,
a
a
one,
5 or
yeah.
something.
See,
you know?
that's what this
Yeah.
basically allows you to do. You don't have to.
But the
return
thing is,
true or
when
false
you're in a switch case, when you're returning, it already returns that Boolean value.
Right.
So in this case, it's redundant, but in other cases, it's quite
So
useful.
like Alex said, if you want to return a 0 or 1, like if this was double instead of Boolean, you could have write 0 or 1 there specifically, instead of just writing true or false.
So that's axis. So the same thing can be done with buttons, like we talked about before. So if you want to say
Go to the slide.
a button, it's easier like this. A button. There are multiple things you can do with buttons. So if you type in case, a button. So return your right controller, get button. So there are multiple functions that you can use for a button. The simple one is get raw buttons, and you type in about your index of your button. And what that does is it has the button been pressed or not. But sometimes you want to use the same button for multiple functions. And when using the same button for multiple functions, for example, let's say we're opening and closing a claw. I want to press a button to open it, and I'm going to press the same button to close it. When you're doing something like that, it's often better if you're getting the button released,
Just use,
and you have your index.
just use press in this case. I feel like press would be more.
So those are the two main forms of input that you can use.
What's the difference between pressed and released?
Press it. You hold it and release it and then.
Yeah, so press is like the initial state where you're going into the button press, right? And then the release is when you're lifting off your thumb off the button, right?
So what do you usually do?
So when
we've been
we're
using release because we didn't realize there was actually a press feature.
no, we've been using press, but we didn't realize.
But why would you want to use release when pressed is more like
No, it's because
makes
when
more sense?
when you're using pressed, you have to, let's say you're doing something that you want, let's say you're opening claw, right? And you want it to open. If you're using press, you have to hold the button down. But if you're using release, then you just have to click the button. So that's the difference.
It's just that press does it on the moment of their instance. And we'll have this debate later. Alright.
Okay. So can someone tell me when would I use an, what's the difference between axis and a trip?
And the what?
Axis or button.
Yeah, so I meant axis or button.
Axis, it has like any value between 0 and 1, but a button, there's only 2 values.
So let's give some case studies. Driving, axis or button.
Axis.
Probably better to use an axis.
Because then you can have a wide range of movement, like your velocity, and you can like slow down easier.
You have a turbo button.
Okay, here's a bit more complicated one. Moving, you know, we had the arm on a robot. Moving that up or down, axis or button?
Axis.
Axis.
Well,
Well, button for
Well,
one.
it depends on like how high you
depends
want.
Because like wouldn't you have to
It
teach
depends on the driver.
Oh, Vinay, like say for like the elevator on our robot for last year or for the previous season, you know how there are like different levels and then you could climb to either this level or this level.
Yeah.
Then you could use like an axis depending on like if there are multiple levels that you have to climb.
But so you have to use a button whenever like something's repeated throughout your competition, and
Like
like
just moving different levels, like you have to go very exact with that, right? You
Yeah,
not just use a button.
Yeah.
Lower level, mid level, top level, right?
so for any repeated movement, you would have to use a
when it
button.
comes to elevator or arm movement, don't use an axis. Like that's just straightforward, right? Because mostly when a driver is using it, you're going at mostly a constant speed, and that too you don't. When it comes to like arm movement or elevator movement, you don't want to give the driver too much control because they can break something, right? Like if they accidentally like just yeet the elevator up, like you're screwed. So you wanna just make it just a button, something like up down movement or something like that.
Or specific set positions if you have the sensors
Yeah,
for it.
like
Or you can have like both, like worst case scenario.
So the thing
you
is
can-
with Axis, so with a button, you're usually using a button to call like some function. And that's a lot more precise than we're using an Axis.
So you're supposed to use a button whenever you have like a repeated action throughout
Yeah,
the
or
competition.
if you want to be precise. If you want to do something at this exact moment, you want to be very precise with it, that's when you use a button. Use a trigger when you don't care that much about the precision. So that's why when driving, they can move fast, slow. We don't want them to move at a constant pace. That's why we're using a trigger.
Couldn't you use a button to have the same purpose as an axis, like through holding down the button and making it repeat over and over
again,
again?
it depends on the driver. Especially me, like I like going at variable speeds and stuff. Because you know when I'm driving around some cases where I go a bit slow, so it's easier to steer in some places. So depends on who you are, but mostly when you're driving, the best case is just using 2 sticks for tank drive.
So that's why it's very important for the programmers and whoever's driving/operating to kind of interact, because some drivers will prefer different things. You know, like, hey, I want it to control this way. So, you know, you work together. You're like the pit crew for a race car driver, right? They tell you, hey, I don't really like this, and can you fix this? Can you update this? I don't like the feel here. You know, it's important to be able to translate that to the programming, right?
So I think like input is probably one of the most simple things. Input and like driving are probably one of the most input is probably one of the most simple things in FRC programming. So a lot of the people who want to get interested in programming, like we're probably going to have them work with people who are interested in driving, get controls set up and that kind of stuff.
Not just that too, like whoever's doing programming and stuff, you guys will mostly be the ones who are like testing and like having to drive the robot in certain situations to make sure it works, right? So a lot of the time, you guys have the better opportunity for driving than other people.
Because
Just bring that up
then
there.
we know how the program works and stuff.
Yeah, definitely.
So now, go back to the slide. This is Axis, we talked about that, kind of talked about buttons.
Okay, guys, that was quick.
So that was quicker than we anticipated, but I left a little bit of time because a lot of you haven't gotten stuff set up yet, so we're gonna make sure everyone has it set up by the end.
So so for next time, I guess the main thing is we're gonna talk about CAN. I might go through electrical setup with you guys. And so we're gonna learn about motor controllers, third-party libraries, different drivetrains. We kind of already went over one today with tank, right? And then robot movement. So what we learned a lot today about like input and stuff. We're gonna learn how we could tie it into output, I guess. You know, how we can move the robot using axis and triggers.
So getting driver input is just the first step. You have to use that input and transition it to actually move the robot. So that's probably what we're gonna be talking about maybe next.
All right. Any questions before we're going to help you guys out? No.
And one thing I'd suggest is, especially if you're not too familiar with like object-oriented Java, we do a lot of turns at you. So I sent a couple of videos in the email. Make sure you watch them, and once you're more familiar with like Java and object-oriented stuff, come back and watch the recording of this workshop and see if you understand it. And feel free to ask those questions. We're always available.
Asking the
How do you
programmer.
program mechanimules? How do you program mechanimules
We'll
using?
get there.
We're
Next.
gonna get there. Yeah, that's where we talked about input today. We'll talk about.
Are we gonna be using those mechanisms?
Alex?
It depends. So I think if we get more people who are willing to do stuff, then we
I
can
mean, you
experiment
know,
with
if we have a lot of people and we split into like 3-hour teams, then you know maybe one of you guys can go for Mechanum. You guys will get destroyed, but
I mean, we do have the wheels and we do have the gearboxes and a chassis to do it if you want.
That's true.
Um,
We could
yeah, it's
try
up
it,
to you.
but we wouldn't get very far.
I just want to say again, you know, if it's kind of a lot, you know, don't worry about it too much. I think the key is a lot of people come in not knowing anything, and that's all right. you
So
know.
raise of hands. How many of you understood nothing of what we talked about today? How many of you at least understood the input-output stuff? That's good. That's good. So how many of you understood the command subsystems?
But once you start going more deep,
Yeah.
Deeper.
It'll get confusing, but the thing to remember is ask questions, and we gave you like a little playground to play around with, so don't be afraid to look online and actually try stuff yourself.
Once you actually do it for the first time and actually go all the way through it, it starts making a lot more sense.
Are there any like free online simulations for testing this?
So we're working on getting synthesis
Yeah.
working, which is just some place where, like an online simulator, like you said, where you can just try out your code without having an actual robot.
Yeah. If you look up Autodesk Synthesis.
Yeah,
You need like a really good computer to run it. So it's
but
like,
that's
Wait, who are you? Are you me or?
I don't know if we tried it on the DS laptop. It's like kind of bad.
So, it takes a lot of setup too, synthesis. So if you're interested in synthesis, talk to us and we'll try to get you set up.
Alright, but I don't think it's worth it. I'll be honest.
But just play around. Chief Delphi. That's
But we
great.
have a lot of time in the summer. We have like 2 robots to work with. Actually, we spent more than that.
So what I just said was Chief Delphi. Chief Delphi is a forum for for FRC, specifically for FRC. There's a lot of good information on there, but it can be kind of tough to find it.
It's the Stack Overflow of FRC.
Yes, and not just that, there's the screen steps that FRC releases themselves that has pretty much everything ready over here.
The thing with the screen steps is sometimes they're too like blunt with it. So it's like you either understand it or you don't. But feel
Like-
free to look over, ask us questions.
I guess in a way it's just a lot of like FRC related terms. Like they'll talk about autonomouses, like what goes on in the field and whatnot. And so, but I think if you just like follow it diligently, and like if you ask us questions like what does this mean, like you'll be like pretty good with it, I guess. Any other questions?
Before we let you guys go. I'll see you guys next Thursday.